Find the equations of the asymptotes of the hyperbola associated with the equation x squared minus 4y squared equals 36. Well, if you look earlier in the book, you'll see that the standard form for a hyperbola that is centered at the origin is x squared over a squared minus y squared over b squared equals 1. So what we'd like to do is we'd like to take the equation that we've been given and put it into this form. And the way you do that is you divide the left-hand side and the right-hand side by 36. When you do so, you will get a 1 on the right-hand side. So when you divide the left-hand side by 36, you get x squared divided by 36 minus y squared divided by 9. And when you divide the right-hand side by 36, you get 1. And now you can see that this equation right here is in the standard form, and that tells us right away that we have the value of a being 6, and we have the value of b being equal to 3. The reason you know those numbers is 36 is equal to a squared. That means that a must be equal to 6, and 9 is equal to b squared, and that means that b must be equal to 3. So when you are drawing this hyperbola, here is the x-axis, and here is the y-axis. We have a box that we need to draw, and that box will go 6 units in this direction and 3 units in this direction. And so the box is going to look something like this. And it also goes across 6 units out this way as well, and up 3 here and across. So what happens is the asymptotes are going to be the lines passing through the origin, which is the center of the hyperbola, that hit these corners, and the other on this side here. So let's go ahead and draw those in. They will look something like this. There's one set, and here's the other set of asymptotes. So the hyperbola itself is going to look something like this. It'll asymptotically approach. Those asymptotes come in and just touch these points right here, and the other side will be just a symmetric version of that. So that's the hyperbola, but in fact we don't want the hyperbola. What we want is we want the equations of the asymptotes. So we want the equation of this line, and we want the equation of this line. So in the first case, when you use the rise over run definition of the slope, this rises 3 and runs 6. So that line right there has an m of 1/2. This line right here, what it does is it rises 3 and runs a -6. So it's got a slope m, which is -1/2. So the name of the lines for the two asymptotes in this case, using the y equals mx plus b form, first one will be y is equal to 1/2 x, because 1/2 is the slope, plus 0, because it's got a y-intercept of 0. And the second line here will have equation y is equal to negative 1/2 x, again plus 0. So those are the equations of the two asymptotes associated with the hyperbola, and the hyperbola, of course, looks like this.